Alright, everyone. This video talks about the question in chapter application of integration. Yeah, let's take a look. For the first one, you're asked to show that the integration of this function is shown in the paper. Yeah, 3x squared over something. So the formula that you will need here is chain rule. You may reopen your notes about chain rule, or you may Google that one. I'll just go with the next one. Yeah, so here I change the form of the roots into 2x cubed plus 9 to the power of a half, just to make it easy. So the y prime will be a half. We got a half from here. Yeah, from the power number, and then multiplied by the derivative of the terms inside the bracket. So it's going to be 6x squared multiplied by the whole thing. This one, a half minus 1. It is minus because this one is differentiation. Yeah. After that, we simplify everything. That's going to be 3x squared, and then 2x cubed plus 9 to the power of negative a half. If we change the form here, that's going to be 3x squared over root of this stuff. But before changing into root, let me change the power first. Yeah, 2x cubed plus 9 to the power of a half. The power will be positive if you change the position of numerator and to become denominator, and vice versa. So that's going to be 3x squared over a root of 2x cubed plus 9. This is the final result, right? Similar things. And then hence evaluate this integration of x squared over the roots with the lower bound 0 and upper bound 2. Use the result in the previous part, yeah, in part A. So you see here, we got 3x squared in the previous part and x squared in the second part, right, in part B. So how to make 3x squared becomes x squared? What do you multiply it with? The things that you need to multiply it with is 1/3 to make it similar. If you multiply 1/3 with 3x squared, the result will be x squared, right? And then this one, 3x squared over something. You see, from in the first part, if you work from here to here, we call that one as differentiation or y prime or dy over dx and such thing. But if we work backwards from here to, let's say from here to here, we call that one as integration. Something with fx dx, like that one. So you do not need to recount these things or these things, just use the result here. So that's going to be 1/3. The integration of this one is this one, the function in the very first part, which is 2x cubed plus 9 with the upper bound 2 and the lower bound is 0. And then you substitute everything, yeah. 1/3 and then 2 multiplied by, oh, I forgot the roots. Wait. 2 multiplied by 2 cubed plus 9 minus, you substitute 0, root of 2 multiplied by 0 plus 9. You will get 1/3, and then this one going to be root of 25 minus root of 9. So 1/3 root of 25 is 5, root of 9 is 3. So the result will be 2/3. The next one, you will need several formulas for that one. The first one is the integration of ln or natural logarithm. The integration of 1 over ax plus b dx is 1 over a ln of ax plus b plus c, right? And then the integration of cos x dx. The integration of cos, that's going to be sin x plus c. And then the next one, the integration of e or Euler number, that's going to be, let's say this one, that's going to be 1 over a e to the power of ax plus c. And there is another rule that you will need here from natural logarithm, which is this one. Ln a minus ln b will be equal to ln a over b. These are the 4 rules that you will need, later here. Now proceed to the integration. If you integrate this one using this rule, that's going to be 6 over 7 ln of 7x minus 4, and then cos is sin, the integration of cos, so it will be 1 over 2. We got 2 here from the derivative of the terms inside the bracket towards x, so 1 over 2 sin terms inside the bracket remains, and then plus 1 divided by a here, e to the power of ax. The a here is negative 3 over 4, and then e to the power of negative 3 over 4x. Do not forget to write the bounds, upper and lower bound, which is p and 1. After that, you substitute everything. Substitute p and substitute 1. I will go with classifying it directly, I'll put my equal sign here because it will be long. 6 over 7 ln 7p minus 4 minus, because not this minus but another minus, because I will substitute 1, right? Minus 6 over 7 ln of 7 multiplied by 1 minus 4. After that, this minus a half sin 2 pi minus pi over 3, and then minus again a half sin 2 multiplied by 1 minus pi over 3. Wait, where is the bracket? Okay, this one. Plus 1 divided by negative 3 over 4, that's going to be negative. Wait, where are you? Minus 4 over 3 e to the power of negative 3 over 4 pi, and then minus negative 4 over 3 e to the power of negative 3 over 4. Oh my god, this one negative 3 over 3 pi over 4, this one. And then if you simplify that one, using this one is the, let's say, the fourth rule. This one the third, the second, and then the first. Using the fourth rule, these two terms we can write it like this: ln 7 pi over 4 minus 3. 7 minus 4 gonna make 3, so it's this one going to be 6 over 7 ln 3 ya. And then this one minus a half sin. We simplify these two terms, which makes 5 pi over 3 plus. Why is it plus? Because negative multiplied by negative gonna make positive. A half sin 2 minus pi over 3. And then this one, we take out the 4 over 3. If I take out 4 over 3, what's inside the bracket will be, hang in a second. Oh, e to the power of negative 3 over 4 minus e to the power of negative 3 pi over 4. These things. And then notice that you should use your calculator in radian for this case, because there is pi that you use in exponential and also in natural logarithm. So in radian, that's going to be pi equals to 3.14. But in calculator, you may put it directly in radian. To change the settings, you see here there is D, capital D here. It means degree. So you need to change into radian. Shift, menu setup, and then choose to degree, radian, and gradient. So you choose the second one, radian. There is small r there, right? So you input everything using that one, especially the sin 5 pi over 3. Let's take a look. Sin 5 pi over 3. That's going to be negative root 3 something. Negative root 3 over 2. Yeah, that's how we use the calculator in radian. Yeah, you need to change the setting first. But just so you know that 5 pi over 3, if it's in degree, that will be 300. And sin 300, the value of sin 300 will be negative root 3 over 2 as well. Let's see. Sin 300. You see, this the results are similar, but here we use the radian because we cannot mix degree and radian in one function. Okay, if you count this one using calculator, this one going to be 6 over 7 ln of 5.997. 5.997 minus a half multiplied by this one going to be negative root 3. Yeah, negative root 3 over 2 plus a half. This one going to be sin of 0.953 since it's in radians, so a half multiplied by 0.1815 plus 4 over 3. You put this one in the calculator, you will have the result of 0.378. If you proceed everything, the result will be 2.87 something, and if you round up, that will be 2.88. That is the final answer for question number 1C. Now proceed to the next one. The diagram shows part of the curve y equals to x cubed. The line y equals to 8 and y equals to 27 cut the curve. So here is the x-axis, and then the y-axis, and the curve is this one. Yeah, it is the curve. And then this line, y equals to 8 and y equals to 27. Now you are asked to find the coordinates. We know the equation, right? Y equals to x cubed. And once you have y equals to 8 and you substitute it into the equation, that's going to be 8 equals to x cubed. And then to find x, you need to multiply x cubed with the power of 1/3. So x cubed multiplied by 1/3 to make the power become ones, 8 to the power of 1/3 also. So this one gonna make x, this one gonna be the cube root of 8, which makes 2. X equals to 2. The coordinates will be 2 and 8, right? X and y. The value of x is 2 and the value of y is 8. The second one, once you have y equals to 27, the same way. So 27 equals to x cubed. Using the same way, we will have the cube root of 27. The cube root of 27 is 3. So the another coordinate is 3 and 27. The first coordinate is A, the second one is B. That's the final answer. And then express x in terms of y. The equation that we have here is y in terms of x. So there is variable x inside the function y. What you need to do is there is variable y in x. So you need to change y equal to x cubed into x equal to something. In order to change x cubed into x, you need to multiply x cubed with the power of 1/3. Just like y. We do on both sides, yeah? This left side will be x to the power of 1. And this one gonna be y to the power of 1/3. So this is the final answer already. Just that. So you may also conclude this one. Fy is y to the power of 1/3. Now use integration to find area bounded by y-axis, the curve, and the lines. Here is y-axis, and then the curve, one I mentioned before, and the two lines, y equals to 8 and y equals to 27. The function that you will use is the function you found in the second part, or part B. And what about the bounds? You see that the bounds there is 8 and 27 because the area is start from here to here. Focus on that one. So the lower is 8, the upper is 27. This one dy, yeah, because it was fy. So integration of fy dy, like this one. Now integrate them. 1 over 1/3 plus 1, y to the power of 1/3 plus 1. And then the upper bound is 27, and this one 8. Wait. Next, 1 divided by this one gonna make 4/3. Y to the power of 4/3, and then this one 27, and then this one 8. So if you simplify this, it will be this one, and then you directly substitute 27 to the power of 4/3 minus 3/4, 8 to the power of 4/3. This one. You can change 27 and 8, right, to be something to the power of something. Let's say this one. 3 to the power of 3. 4 over 3 minus 3 over 4. 2 cube 4 over 3. Just in case you do not use calculator, and actually you can do that in calculator, but just in case. The next one is, oh yeah, we cancel this one, right? 3 and 3, because 3 multiplied by 4 over 3 gonna make 4. And then this one going to be 3 over 4 multiplied by 3 to the power of 4 minus 3 over 4 multiplied by 2 to the power of 4. 3 over 4 multiplied by 81 minus 3 over 4 multiplied by 16. The next one, this one gonna make 60.75 minus 12, and the result will be 48.75 square units. This is the final result. Going next, it will be this one. So you are given the integration of something is 256. So you integrate the stuff on the left first. If you integrate this one, the result will be, wait, let me put in detail, 2 plus 1, yeah, just like how we do integrate in basic rules. 2 over 1 plus 1, x to the power of 1 plus 1 plus ax. And then this one going to be 6 and 2 equal to 256. Do not forget to write the 256 because you will need that one, just in case you will forget. Write them down completely. So 3 divided by 3 gonna make 1. No need to write them. So x cubed plus x squared plus ax equals to 256. The next one, you substitute everything. It becomes 6 cubed plus 6 squared plus 6a minus, do not forget the bracket, 2 cubed plus 2 squared plus 2a equals to 256. Count everything. So 216, 36 plus 6a minus 8. It is minus because you expand the negative sign here into the bracket. Minus 4 minus 2a. If you count the numbers without the variable a, that will be 240. 240 plus 4a equals to 256. So later on, you subtract 240 on both sides. It will make for a will be equal to 16, and a here you divide 4 on both sides. Yeah, 16 divided by 4. A gonna make 4. This is the final result for number 3. Going next, about this one, you are given two functions fx and gx, and then to find the coordinates of p and q. Actually, finding coordinate of p and q, which is on x-axis, this one x-axis and this one is y-axis, is quite easy because you learn this one in GH2, yeah. You can use factorization, and then what was that again? Or ABC formula, or also graphical method. But here, the graphic I provide do not provide you with the numbers of x, and the scale is different between x-axis and the y-axis, right? So you may factorize them. If you factorize the f-axis, it will be x minus 2 and x minus 4. X minus 2 and x minus 4 equal to 0. So x minus 2 equal to 0, the value of x is going to be 2, and x minus 4 equals to 0, the value of x is going to be 4, right? So here on P, the coordinate P will be 2.0 and the coordinate of Q gonna be 4 and 0. Judging by the graph, we can directly notice that the coordinates here, not the coordinates, the point here will be 5, right? So it's like 4 units make 2. 4 units make 2, it means 2 unit makes 1. That thing. So here 2 unit makes 1, 4 plus 1 gonna make 5. And then to find R, to find the coordinates of R, you substitute 5. Wait. Substitute 5 to fx. Later you will find the value there. The coordinate of y will be 3. Oh, let me put 5. F5 will be 3. So here is 5.3. Another way to solve this one is using fx equals to gx, and then you kind of factorize the whole thing. For that one, it's a little bit complicated, but here is the look, yeah. So fx equals to gx. So here we have x squared minus 6x plus 8 equals to x cubed minus 10x squared plus 32x minus 32. This one. Make all of the terms in one side, let's say on the right side. So x cubed and then this one negative. This one will be negative, right? 11x squared. We got 11 from negative 10 and negative 1. Negative 1x squared here. And then plus 32 plus 6x. That's going to be 38x. This one gonna be 6x on the right because we add 6x on both sides. And then this one minus 32 and minus 8, minus 40. So you can factorize these cubic functions. But factorizing cubic functions somehow a little bit difficult, so you can use this one. X cubed minus 11x squared plus 38x minus 40. So here do you notice that this one x minus 2? So we can use that one. X minus 2, let's say. And then x cubed divided by x, gonna make x squared. And then you multiply this one with 2 terms. X squared multiplied by x gonna make x cubed. X squared multiplied by negative 2 gonna make negative 2x squared. And then you subtract. This one going to be negative 9x squared. And then this go down because there are 2 terms here, right? 38x. And then negative 9x squared divided by x gonna make negative 9x. Negative 9x multiplied by this gonna make this one. And then this one negative multiplied by negative gonna make 18. You subtract it again. This one gonna make 20. Oh yeah, 20. And then the 40 goes down. Minus 40. 20x divided by x gonna make 20. 20 multiplied by x gonna make 20x, and then 20 multiplied by negative 2 gonna make negative 40. The remainder is 0. So this stuff is equal to x minus 2 and x squared minus 9x plus 20, right? Oh, by the way, this one is to find the intersection points between the 2 curves, the fx and gx. So here, continuing this one, if you factorize the quadratic equation, this one, it will make x minus 4 and x minus 5. Well, we already have x minus 2. So here we have x equals to 2, and then x equals to 4, and x equals to 5. That is another way on how to find the intersection point. This one. Okay. The next one. Find the area of A and B, then the total area of A and B. To find the area of A and B, I already mentioned that you need to analyze the graphic and then judge the lines. Which one is the top one, which one is the bottom lines, like that one. For area A, the lines look like, this one, yeah, area A. Looks like this one, right? The top one is the GX. The bottom one is the FX. So to find the area, it is the top line minus the bottom line. So it's going to be GX minus FX. Oh, I forgot this one. And then what will be the upper bound and the lower bound? You see this one in the graph. Since we use dx, so focus on the number of x that we have here. This part and this part. So it's 2 and 4, like that one. 2 and 4. And then you substitute everything. The substitute of gx. Gx was x cubed minus 10x squared plus 32x minus 32 minus the whole thing. Do not forget the brackets, yeah? Fx is x squared minus 6x plus 8 dx. And then you expand this one first if you want. Negative multiplied by positive gonna make negative. Negative multiplied by negative gonna make positive. Yeah, that terms. But I'll go directly with this one, yeah. X cubed and then negative 10 and negative 1. Gonna make negative 11x squared, 32x and positive 6x plus 38x, negative 32 and negative 8. That's going to be negative 40. Do not forget the dx. And then we integrate them. We haven't integrated until this level. We haven't integrated yet, yeah. It's only simplification. I am simplifying the terms. And then if we integrate, that's going to be, oh, no, I don't need this thing. If we integrate, that's going to be 1 over 4 x to the power of 4 minus 11 over 3 x cubed plus 38 over 2x squared minus 40x, and the upper bound is 4, the lower bound is 2. And then we substitute everything. 1 over 4 multiplied by 4 to the power of 4 minus 11 over 3 multiplied by 4 to the power of 3, 38 over 2 multiplied by 4 square minus 40 multiplied by 4. Let's use the bracket to make it more visible. Minus, do not forget again the bracket. Some of you might kind of be like, oh yeah, no need to bracket, and then get it wrong. 2 to the power of 4 minus 11 over 3 2 to cube, which where was I? Oh, 38 over 2 square minus 40 multiplied by 2. If you count everything in the calculator, I have counted before actually. This one going to be negative 80 over 3 minus negative 88 over 3, which makes 8 over 3. This one is the area of A. Now the area of B. The area of B looks like this one, yeah. You see, this one, the top one is, let me see, the top one is fx, and then the bottom one is gx. Just like before, that's going to be top one minus the bottom one. And the bounds will be, you see again the graph, and focus on the x value, 4 and 5. This one and this one. Right? After that, you substitute everything. The fx was x squared minus 6x plus 8 minus the bracket x cubed minus 10x squared plus 32x minus 32 dx. You expand everything, the negative, into the bracket, and then we simplify. I will simplify from the highest power, which is 3, negative x cubed, and then this one positive and also positive, plus 1 plus 10x squared, 11x squared, and then negative 6x and negative 32x, negative 38x, and then 8 plus 32, gonna make 40. This is the final expression of fx minus gx, and then you integrate that one. That's going to be negative 1 over 4x to the power of 4 plus 11 over 3x cubed minus 38 over 2x squared plus 40x, and the upper bound is 5, the lower bound is 4. This one. We do the same thing as this one, yeah, just like this one. You substitute 5 and 4. Meanwhile, in the previous one, we substitute 4 and 2, right? So, if we substitute 5 and 4, 5 to the power of 4 plus 11 over 3, 5 to the power of 3 minus 38 over 2, 5 square plus 40 multiplied by 5, bracket, minus the whole thing but with different value of x. Negative 1 over 4, 4 to the power of 4 plus 11 over 3, 4 to the power of 3, and then minus 38 over 2, 4 square plus 40 multiplied by 4. This one. If you count it in calculator, you will have 5 over 12 as the final result. This one, area A and area B, and then you find the total area. Make sure you read the whole questions, yeah, so you will know what's to answer. And then the total area, just add them together. The total area, 8 over 3 plus 5 over 12. We make the denominator equal. This one, 12 divided 12 divided by 3 gonna make 4. 4 multiplied by 8 gonna make 32. And then this one, so it's 37 over 12 square units. Okay, that is the final explanation of these papers. Okay everyone, see ya.